Alright guys, the following video is 8.5 variation functions. There's going to be 4 different types of variation functions that we're going to talk about, variation equations. The first one is direct. The direct variation equation is a relationship that can be expressed in the form y equals kx. So in words, it basically means that y varies directly as x if there is some non-zero constant k such that y equals kx. K is called your constant of variation. So then, for example, if y equals 3x and x equals 7, then y equals 3 times 7, or 21. Now, basically what this starts off as looking at like is slope. All right, slope is a fancier word for a constant of variation. All right, think about how your slope talks about how much your line moves. Right, slope of 3 over 1 is rise over run, rise 3, run 1. So essentially, it's the same thing as the slope. Now you can use that if you know that the y varies directly as x, and you know one set of the values. You can use the proportion to find the other set of corresponding values, because the k's will always be the same in any individual problem. So since you know that it varies directly, then these k's have to be the same. So that's why it solves. You take your first set and you solve it for k. You took your second set, solved it for k. And then since these k's have to be the same, since they vary directly, that lets you set these equations equal to one another. So for the first type of problem, what you're going to see today is we're going to talk about each different kind of variation: direct, joint, inverse, and combined. For each one of those, there's going to be a different equation that you can have solved for. And what you're going to see is that we're going to use these equations to figure out our missing value. So the difficult part of this lesson is keeping these equations straight. You will have to memorize these. You can also memorize it this way and know how to solve for it. So y varies directly as x would be y equals kx. So the first one, if y varies directly as x, then y equals 15 when x equals negative 5. Find y when x equals 7. Okay, so for example, just to show it, you guys start with your y equals kx equation. That's for your direct variation. And since you know that it's going to be very directly, you're going to solve for k every time. So that leaves you with dividing by x here and x here, which is why we use this y equals, or y over x equation. So we know, it tells us that it varies directly, and we know y is 15 when x is negative 5. So we have 15 over negative 5. We know that. So then, since we know it's the same variation, since we don't know what that constant is, but we know it's the same for this set of points here, for the 15 and negative 5, as it will be for this set of points here, y, whatever that is, and 7. So that's why you can set it up the exact same way on the right-hand side as a second y over x, because they have the exact same k. So equals, you can put y or y2 if you want, and they tell you that x is 7. So that's the setup to it. You figure out what type of variation you have, which is this case direct. It'll say varies directly. Then you use y over x, or you use y equals k times x and solve for k. Either way, you'll be given one set of points. So you plug them in, 15 over negative 5, and then you'll be given a second set, one of which will be missing. So you don't know what y is, so that's your missing variable. You know x is 7. From there, you just solve the proportion. So 15 over negative 5 reduces to negative 3 over 1. And then you cross multiply. So y equals negative 21. Alright, now the second type of problems with direct variation is honestly not that much different, but it can throw people for loops. It's when they switch the variables on you. Okay, so if it's one like this, if r varies directly as t, and r equals negative 21t equals 4, find r when t equals -6. So on this one, they switch up the variables. But if you read it just like the last one, you'll see the last one said if y varies directly as x. In this one, it says r varies directly as t. So for, whoops, wrong thing. So in this one, r is varying directly as t. So r is acting like y, t is acting like x. So then you still solve this for k. So the equations you want to use is r over t. So r over t equals r over t. So r1 over t1 equals r2 over t2. And then you would use these equations. Okay, so that's going to be your first question. Use these equations, y1 over t1 equals r2 over t2, to figure out what r is. If r varies directly as t, r equals -20 when t equals 4. Find r when t equals -6. Okay, so hopefully, excuse me, hopefully you got r equals 30 with this one. You got r1 over t1 equals r2 over t2, like I said. Tells you r equals -20 when t equals 4, so that's one side of your equation. Find r when t equals -6. -20 over 4 reduces to -5. Cross multiply to get 30. So that's the way these problems go today. We're going to learn all four different types, all four equations, and then we're going to use those to solve for missing variables. The next type is called joint variation. When joint variation happens, it occurs when one quantity varies directly as the product of two or more other quantities. So it's going to look very, very similar to direct variation. The only difference is you have an extra variable. So if y varies jointly as x, as y equals kx, then or if y varies directly as x, it's y equals kx. But if y varies jointly as x and z, then it's just y equals kxz. So it's the exact same equation as the direct, except you have this extra variable of z in there. Where that changes for your solving for problems is instead of just dividing by x here, you got to divide by z as well. So your problems, your proportion equations you're going to use is y over xz equals y over xz. So that's what the work down here shows, is that for your two separate points, each time you got to solve for k, and then use the k's to set the equations equal to one another. So it's y over x z equals y2 over x2 z2. So an example of that one would be something like this. Suppose y varies jointly as x and z. Find y when x equals 9 and z equals 2. If y equals 20 when z equals 3 and x equals 5. So it's important to know, that your starting equations. So y equals k xz, and for this one you want to solve for k every time. So it goes to y over xz equals k. So you can use those two equations. So y 1, that wasn't really 1, there we go, over x1 z1 equals y2 over x2 z2. Okay, so now we need to find y. So we don't know a y, but we know x is 9 and z is 2. And it tells us y is, the other set of points is y is 20 when z is 3 and x is 5. Okay, from there you clean it up a little bit. So 9 times 2 gives you 18, which gives you 20, 15. I actually just cross multiplied this one out right here. You can reduce if you'd like, but you're gonna have to eventually cross multiply anyhow and still divide. So I went 15y equals 360 and divided by 15. So y, let's get that out of the logo. Let's go over here. There we go. Y equals 24. And there you go. This just depends on what type of variation you're talking about as to which equations you use. And then, like I said, it's important to know these. I think if you know these, it's easier to do it than just trying to memorize all this. Because if you know these, you know you can solve for k. So know that direct is y equals kx. Know that joint is y equals kxz. Because then you can just solve for k, so you know what you need to use. Also, that way, in case your variables change, like segue to this one, then you can just plug these in. So suppose r varies jointly as v and t. So r is acting like y, so r goes on your left, v and t go on your right, and then you can just solve for k again, because k will always be there. So for this one, I'm not going to do anything for you. You got to figure out the equation to use, and then suppose r varies jointly as v and t. Find r when v equals 2 and t equals 8, if r equals 70, when v equals 10 and t equals 4. Alright, so for this one you should get 28. Like I said, r equals kvt, solve for k. So divide both sides by vt, so r over vt. Plug everything in, so you're finding r when v equals 2 and t equals 8. If r equals 70, when v equals 10 and t equals 4. Multiply your denominator, so 8 times 2 gives you 16, 10 times 4 gives you 40. I skipped a step where I reduced these by 10, so 7/4, and then cross multiplied. So I got 4r equals 112. You might have gotten 40r equals 1,120. Either way, you should still get r equals 28. So there's two of the types. Third type's a little weird. Third type's called inverse variation. Inverse variation occurs when the product is equal to a constant k. So it'll say if y varies inversely as x, if there is some non-zero constant k such that xy equals k, or y equals k over x, either way. So inverse is whenever they multiply together to equal k, which is pretty nice because then you can just have x1, y1 equals x2, y2 like this. And then they divide it for the y's. You really don't need to because you're going to be able to do that work anyhow. So just set it up as x1, y1 equals x2, y2 for this inverse one. And that's where the variables really don't matter too much as long as you get the same pairs, So if it varies inversely as b, and a equals 28 when b equals -2, boom, right there's a pair. So 28 times -2, and that's wanting to find a when b equals -10. And so there you go. It's inverse is really kind of the easiest one there is. So a1, b1 equals a2, b2. And so we're solving for a. So 28 times -2 gives you -56 equals -10a. And we're going to divide both sides by -10, which gives you 56 tenths, reducing that to 28, oops, not 25, 28 fifths. So inverse is really the easiest one because you just have the products of the two variables equal that constant, and for that reason the setup is very, very easy. That's all I really got to say about that. There's nothing really to them besides just remembering that that's what you do for inverses. So from the next one for you guys is x. If x varies inversely as y, and x equals 24 when y equals 4, find x when y equals 12. Okay, so the next one here, if x varies inversely as y, and x equals 24 when y equals 4, find x when y equals 12. Hopefully you got 8. 24 times 4 equals 12 times x. 24 times 4 divided by 12 gives you 8. Alright, last one's probably the most difficult just because it's the most variables involved, and it's the one called combined variation. Combined variation is when one quantity varies directly and or inversely as two or more other quantities. So the setup is basically like this. So you're having y equals still. You're varied directly as one, but you're varying inversely as another. So this very inversely variable could be here on the denominator. The directly one's on top. Whenever you're not solved for k. The opposite of that, whenever you do solve for k, which is what they do to down here, is then it's going to be the flip-flop. So because you got to multiply by this reciprocal, multiply by z, divide by x. So if you know that y varies directly as x, like it does here, y varies inversely as z, like it does here, in one set of values, then you can use a proportion to find the other set of corresponding values. So my best advice for combined variation is to kind of pay attention to what you're doing up here. So if you look up here top, you have it directly on top, but when you plug it in, your directly is going to be on the bottom because you got to solve for k. Your inversely is on bottom up here, but it's going to end up being on top, so you got to put when you solve for k. So it's the opposite of what you think it would be. It's the hardest one, it's the most confusing one. So just pay attention to what your where the words are in the problem. Pay attention to where the numbers go correspondingly to that. Okay, so for example, suppose f varies directly as g and f varies inversely as h. So whenever we have it like that, f is on the left. We know that k is on top, and we know it's varying directly as g, which means it's on top, and inversely as h, which means it's on bottom. Then whenever you solve for k, you're going to multiply basically by the inverse of that, or the reciprocal rather, which would be hg on both sides. So that means that whenever you set up your proportion, it'll be f h over g equals f1 h1 over g1. Because you have to solve for that k and then use those two separate, because that k is the constant, which we know is the same, and so that way it's set equal to each other. So suppose f varies directly as g, f varies inversely as h. Now we have that here. Find g when f equals 18 and h equals -3. So we have 18 times -3 over g. If g equals 24 when h equals 2 and f equals 6. So we're going to do some simplifying here. 2 times 6 gives you 12, and 12 over 24 gives you 1/2. I should have done the other way first, my fault. So 18 times -3 gives you -54. Let's do that over g, which equals 1/2. So then you cross multiply. G times 1 gives you g, and then -54 times 2 gives you -108. Okay, so like I said, probably the biggest thing to take away from this lesson is knowing these formulas. So for inverse, combine, direct, and joint, know these. That way you can just solve for k, because then it doesn't really matter what your variables are. As long as you know the first one goes on the left equals and the rest goes somewhere over by k, from there you can just solve for k, because you guys can handle that. So last one for the day here, or for this video. Suppose p varies directly as r and varies inversely as t. Find t when r equals 10, p equals -5, if t equals 20, when p equals 4, and r equals 2. Alright, so the last answer should get t to equal -80. So once again, set it up with your from combined variation. So p on the left, k varies directly as r, so r's on top, t's on bottom. Solve for k, that's what you use over here for your proportion, and then you plug in the variables, get it down, solve, get t equals -80. So make sure you memorize, make sure you kind of learn those formulas, because those will not be given to you. You'll have to know those. Know which kind means what, combined, jointly, inversely, and directly. Homework for this, guys, is page 566, 8 through 24 even, along with 11, 21, and 23.